Kia ora everyone, I'm Tina Frew, Head of Sustainability with Meridian Energy, and welcome to the first of our Tackling Zero webinars. Tackling Zero is where we offer Meridian's insights on topical sustainability issues. With the recent introduction of climate standards in New Zealand brings with it a stronger focus for many organisations, including us, to understand the impacts from a changing climate and using scenarios and climate data to help with that. I know that there are a lot of people out there stepping into this area for the first time or just generally interested to learn more, and so I'm very privileged to welcome Dr Jen Purdie, Senior Research Fellow at University of Otago, as our first Tackling Zero guest. She's an expert on climate change who's looked extensively at how it could affect our energy systems. We're going to start by hearing from Jen on what climate change will mean for the demand and supply of energy in New Zealand.
The demand side, we're going to double demand in 30 years by electrifying a whole lot of stuff. There's also some more subtle changes which are going to come from, we're going to need less heating load, which of course impacts that winter evening peak. In winter when demand is the highest in the whole year. And we're going to need more air conditioning load in summer and possibly more irrigation pumping because we're going to get more droughts down the east coast. If I go now to that supply side, New Zealand electricity is about 55% hydro and currently about 6% wind. And that wind and solar proportion is growing madly fast. We're going to be 99 or 100% renewable electricity by the mid-2030s, and that brings in this increased intermittency. So when the wind stops blowing and the sun stops shining, we're going to have a solution for what we use to generate. And in a wet year, that's fine, that's hydro. So we hold the water back behind the hydro lakes, behind the gates, and then when the wind stops blowing and the sun stops shining, we open the gates and let the water go and generate with that. Easy, but if we get a dry year, then we've got a problem. So New Zealand's got quite a significant dry year risk. About every sort of 3 to 5 years, we get a significant dry period, and then at the moment we burn coal to generate with. So in the future, we've got to come up with that solution. And the Interim Climate Change Committee in 2019, I think it was, said that we should not get rid of that last 1% of gas in the system, that we should hold on to that so that when we do get a dry year, we can turn on those gas turbines. They wouldn't be used very much. There'd only be a tiny part. And that sort of goes to show that what we should be aiming for is not 100% renewable electricity, but maximum decarbonisation, which means we retain a little bit of gas to give us a secure and solid electricity system. But as a result of that, we can electrify heaps and heaps of cars and a whole lot of industrial heat applications, and get rid of something like 30 million tonnes of CO2 just by doing that.
Yeah.
So on top of that, just one last thing on the supply side is that our wind and water is changing over time, and expected to change quite a lot in the next few decades. So we're going to get wetter on the west coast and drier on the east coast. We're going to get windier in the south and less windy in the far north. And quite significantly in our big hydro lakes, which are all in big mountainous snow-fed catchments in the South Island, we're expecting some of that water, which now arrives in summer, and we have to store it until winter, which is when we need it to generate with. In the future, it's going to be less snow melt, and there's going to be more rain in winter. So we won't need to store so much. It'll arrive in winter when we need it. And that's a good news story. So that seasonality is going to change quite a lot. But we're also expecting bigger floods because if you warm a parcel of air by 1 degree, it can hold 8% more moisture. So just because of that and because of a whole lot of other reasons, we're going to get bigger floods. And the question will be in the hydro lakes is if we can hold that water back and store it, or if it will just all spill down the river. So those are the main sort of changes in the energy sector, which is quite a lot.
Yeah, no, it is. And it's really interesting to think that a changing climate like that could have some, positive things like that, like aligning those inflows with when you need the demand over the winter. Just digging into adaptation, you mentioned that before, and kind of getting a bit more focus alongside those reducing emissions. So at a practical level, what are some of the things that go through your mind when you think about some of the actions we might need to take, and kind of specifically thinking about the energy sector?
Yeah, so I've already mentioned that floods are going to get bigger, and the question will be how damaging will those floods be, and will the infrastructure be able to stand up to them, and also will we be able to capture that water, Or will it all just spill over, down the spillways and away because there'll be too much of it? The other question with wind is that we're expecting wind speeds to get faster in most of the country, and big wind turbines, when the wind speed gets too strong, they actually don't want to get damaged by that wind, so they turn off and turn away from the wind. So the question is, will the increased wind reach the point where all the turbines turn off and turn away from the wind, and we can't actually reap the benefits of that increased wind? Or will it all just be a little bit of an increase and we'll get more generation from it, which will be really helpful? In New Zealand, all the wind and hydro is quite highly correlated. When it blows somewhere, it's blowing everywhere, except maybe the far north and the far south. And also, when it tends to be blowing, we get most of our wind from the west. It tends to be raining in the big mountains as well, and so the water coming in is correlated with the wind. So that's a negative thing about being such a small country. In some of the bigger places like Europe and America, it's blowing somewhere, and they can bring that power in. So that's one thing we have to adapt for. But generally, over the whole country, that will impact on our transmission network as well. Stronger winds, and sea level rise as well. There's not much hydro infrastructure around the coast, but sea level rise, we're expecting something like a sort of a half a metre to a metre of sea level rise, and globally 150 million people live within a metre of sea level. So have you got a spare bed at your house? There's going to be a lot of people looking for a new home. So there's going to be global impacts as well as local impacts. And things like bridges and dams, we need to think about with winds and more water, and we're already seeing bigger floods in some places. And in the east, generally, where most of our agricultural areas are, we're expecting to see some bigger droughts in some areas, and so that will impact things as well. And there's a lot of things that you might not even think of with the energy system. When in the summer, our transmission lines can carry less electricity than in the winter because they get hot and they sag down towards vegetation. And so if our temperatures get much hotter, then our lines may be able to carry less. So, there's a lot of impacts that we have to think about.
There's a lot definitely going on in that space. So you kind of mentioned earlier that, we're obviously pushing to increase renewable energy consumption in the country, and just thinking about how you think that might play out, noting, New Zealand's unique emissions profile, and kind of what difference would a fully renewable energy sector make?
Mm-hmm. It's important too to isolate energy or electricity. So we're 85% renewable electricity already, but the New Zealand energy sector is only 40% renewable. And that's a lot of our non-renewable electricity comes from transport. It's burning fossil fuels. And so, as I've said, a strong, robust electricity system is going to enable us to decarbonise transport, which is huge. So that's going to give us a massive, that's the low-hanging fruit in a way for New Zealand. The agriculture is most of our emissions, or 50%, but it's a harder one to tackle, whereas decarbonising transport is hard, but it's easier probably than some other things. So, the last government had a target of 100% renewable electricity, and I think that's probably a mistake. And I think both the Interim Climate Change Commission and the Interim Climate Change Committee and the Climate Change Commission have both mentioned that's a very expensive way of reducing emissions. If you can retain a little bit of gas for peaking and for those dry years, then you can have a really strong, robust electricity system to decarbonise a whole lot of other energy applications. So I think 100% is the wrong target. The target is maximum decarbonisation. And, there's a plan to get there. We should be able to do that. The coal is naturally going to retire. They've been testing biofuels in the Huntly Power Station, which is our last remaining coal power station, because they're going to phase out of coal, and they'll either close that station down or they'll try and run it on biofuels. So the transition is happening. It's definitely going to happen. And we'll get there, but there may be a few speed bumps along the way.
It's interesting you mentioned biofuels for those out there that may not be close to that. So how do those work, and what kind of use cases does that relate to?
Yeah, well, they'll only ever have a small part to play in the total energy system because they require a lot of land to grow. And so that's things like, I can't think of the crops off the top of my head, but there's various biofuel crops that you can grow
Yep.
to get biofuels, and they can be used in all sorts of applications. I mean, I was really surprised that they're thinking of using them at Huntly, which is a coal-fired power station, but that is one application. They can also be used for transport. And the two big unknowns when you're planning transport in New Zealand, it's fairly certain that all the light transport will be converted to electricity, and there's also the smaller trucks will probably be electric as well. Although the bigger truck you get, the bigger the batteries get, and then they can't carry enough batteries to drive themselves. There's the biggest trucking firm in New Zealand is testing out dual fuel already with diesel and hydrogen. So they have a hydrogen tank and a diesel tank, and they drive on the hydrogen until they run out, and then they switch to the diesel because there's not many refueling places for them. So definitely hydrogen and biofuels will have applications, and will have a part to play. Yeah.
Great, great. And there were lots of exciting things you kind of mentioned through some of the questions, but also some things that could leave people feeling a bit hopeless. Like there's some scary kind of topics raised in there. So just from everything you've been across, like how confident are you that we could make a difference, and what gives you hope at the end of the day?
Yeah, well, a couple of things that you sort of have to retain hope, or you just go to bed and put the covers over your head and try to ignore it all. I think there is hope. Two things in history that we got rid of CFCs. The Montreal Protocol was signed by the whole world in 1976, and CFCs were dealt with. They were converted to other uses, other types of components, and the ozone hole has slowly been closing. So we did that globally. We moved from 100% horse to 100% car in about 10 years, or about 15 years in the early part of last century. So we can change quickly when we want to. That was a radical change. So those two things. But also, I've been working in this field for about 30 years now. And when I started, the projections were for a 4 to 6 degree warming for the planet. Now, 6 degrees is pretty much an uninhabitable planet, and that's what we were facing. 4 degrees in some ways is scarier because much of the planet would be uninhabitable, and so there would be a lot of fighting over what was left. So that's really scary as well. But now, although unfortunately it's starting to look like we're going to miss that 1.5 degree target that everyone's been hoping for, there's a possibility if everyone does what they said they're going to do, that we'll reach 1.8, and that's entirely livable. We're going to have to make adjustments. It's not going to be small, but even with great global geopolitical instability, we still probably will manage to get 2.7 degrees, stay below 2.7 degrees warming. Now, these are still big numbers. They still have dramatic impacts. And the trouble is, like I mentioned before, the feedback loops are really unknown.
Yeah.
So once you get past 2 degrees, we might be all right, or the West Antarctic ice sheet might collapse and sea level might rise 8 meters, and several 100 million people will need to move, and that will create huge disruption on the planet. So that's the trouble with anything over 2 degrees, is we're not sure. Sorry, I meant to be giving you hope. However, we're not looking at 4 to 6 degrees. So the thing to me is keep pushing governments. And I did just want to say a great quote from Dr. Michael Mann. So, I mean, I would say to everyone, don't fly if you possibly can avoid it. You don't need a holiday in Fiji. We've got great places here to have a look at least until they come up with a solution for aviation fuels, which a lot of people are working very hard on.
Yes.
And Europe now has planes that can do 250 kilometres with 20 people on board, electric planes. So it's coming. Meantime, try not to fly. But I would quote Dr. Michael Mann, who's a very famous climate scientist, and he says the biggest single way to have an impact on climate change and other environmental crises is through collective pressure on policymakers to act in our interest rather than special interests. And I think that is the key. Keep pushing your government to not be swayed by the oil lobby, but to work in our interests.
Yeah, that's really good to have some practical hope in there. Thanks, Jen, and sharing some of that context. I think we've got a little bit of time for a couple of questions that have come through. So, first one, you talked about building more renewable generation won't solve the dry year problem. How about overbuild?
Yeah, so there's like 4 or 5 solutions to the dry air problem. One is overbuild, where you build thousands of wind farms so that something's spinning somewhere. That's one solution. We're going to have it's going to there's 2 approaches. There's a pumped hydro scheme where you which has been shelved at the moment, but there was one being talked about for Lake Onslow in the South Island, where you get all that excess water, as I've mentioned, in summer, which is coming into the lakes, but you don't need to generate with it. You use it to generate, and you pump the water uphill, and you hold it uphill in a high lake until you need it in the winter, and then you bring it down. So that's a solution to seasonal dry risk. So that's one event. The other side of the coin is the portfolio approach, which is what they talk about, which is a whole lot of little things all working together to solve that dry year risk. You'd have some overbuild, you'd have some grid scale batteries, which are good. They can really only shift load around within the week. So, from the middle of the day when the sun's shining to the evening when everyone needs the power. There would be some biofuels and hydrogen used for electricity generation. You can store energy in hydrogen and then convert it back to electricity if you need to. It's expensive, but you can do it. And a big part of this is going to be demand response. So already in New Zealand, when big industry comes to an electricity provider and says, we want some electricity, the electricity provider says, well, only if you provide demand response. In other words, if in the middle of winter at 6 p.m. when everyone wants the power and the lakes are a little bit low, then big industry can back off for a few hours and let other people use that power. So we'll need a lot of demand response. And that's there's also going to be a lot of distributed energy, so rooftop solar, but that does tend to generate in the middle of the day, not when you need it, which is in the evening. So there's 2 sides to it. There's pump storage, which the current government has said is just going to be shelved. We're not going to do that, but the plans are still sitting there. And then the other side of it is this portfolio approach, which is a whole lot of little things, which do all add up. I mean, I do electricity system modelling, and it does all add up, but it will require a whole lot of coordination.
Yeah, it's helpful. Question here from Simon. What is the risk that IPCC projections are too conservative and that the climate will change quicker and more severely than anticipated? If so, how do we kind of manage and plan for risks that might come from that?
Yeah, that's a great question. There's a lot of uncertainty around the projections, absolutely. They do run their models back through time, so they run them back 50 years, and therefore they can see if they're performing well because they've got the observations to compare them with, and they do work quite well. So there is a reasonable amount of confidence. The error bounds are wide around the projections, but that's why we do these scenarios. So which we talked about earlier. If it's a low emissions future and there's not many impacts, how do we act? What do our policies look like? And then if it's a high emissions future, how do we act, and what policies do we need in place? And ideally, you'll have policies and adaptation all set up so you're ready for any eventuality, although that's impossible. You do that as much as you can. So it's there is a chance. The biggest risks are the feedback mechanisms. And the tipping points. So, for example, this Atlantic current that I talked about, the Atlantic meridional overturning circulation, is like a big conveyor belt in the ocean that carries warm water from the equator up towards the North Atlantic. And it makes the Britain a few degrees, or the UK a few degrees warmer than it would otherwise be, which is quite significant. And that's weakening. So because of the changes, all the first adapter, if you like, of climate change is the ocean. So the ocean soaks up a huge amount of heat. If we hadn't had the ocean here, we would already be several degrees warmer than we are now. So it's already soaking up a lot of heat, which is helping us. But the result of that is that it's having an impact on these currents. So so the risk is that current suddenly flips around. I mean, it's weakening, that changes direction or something, and you get a regional impact where a region will change quite dramatically. So there's those 2 things that are the biggest risks. But I guess we have to do something, and we have to plan. And so having reducing emissions as much as we can, number one, and then planning with scenarios. I would like to say that New Zealand is grossly insufficient in our emissions reductions as a per capita fair share of our global task. New Zealand is not doing well at all. So we do need to do more, and pressure on government to do more is always a good thing.
Thanks, Jen. That was really helpful. And I see there's some really good questions here, but I think we're sort of at time, so we'll have to commit to follow up afterwards with those. So thank you very much, Jen, for coming along and taking the time to speak with us and sharing your insights. That was the first of our Tackling Zero webinars. Anyone, as I mentioned, if there's any further questions that you haven't dropped in the chat, just email corporatecomms@meridianenergy.co.nz and we'll get back to you. So if you haven't already, as well, sign up to our Tackling Zero newsletter, and we look forward to seeing you next time. Ka kite.